This class we work out 5 problems on application of Kirchhoff's voltage law in terms of loop method or Maxwell's mesh method. Problem number 1. In the circuit of figure, find the value of R and the current flowing through it. If current through branch OA is 0, that is the question. I redraw the diagram like this, same diagram I redraw like this. This is 10 ohm, this is 15 ohm, this is 40 ohm, this is resistance R, unknown resistance R, this is 20 ohm, this is 100 volts. Now I write the loop equation. I consider loop 1, B, A, O, this is A, B, C, B, A, O, 10 I1 plus 0 minus 40 I2, that is equal to 0. 10 I1 is equal to 40 I2, therefore I1 is equal to 4 into I2. Next I consider loop ACO, 15 I1 minus R into I2 plus 0 is equal to 0. Therefore 15 I1 is equal to R into I2. I know I1 is equal to 4 I2. So 60 I2 is equal to R into I2, I2 into get cancel, R is equal to 60 ohms. The resistance value of R is equal to 16 ohms. It is something like a Wheatstone bridge. So 10 by 40, that is 1 by 4. 15 by 60, that is equal to 1 by 4. That's the thing. Now I have to find the current. What is the current flow through the resistance R, I2? If both resistance are equal, that naturally the voltage is same. The current flow through the AO is equal to 0. Anyhow, I wish to find the current through the resistance R. Now I have form a Maxwell's mesh matrix. Diagonal elements. First I have to find the diagonal elements. First this is loop 1, this is loop 2, this is loop 3. This is I1, I2, I3. I choose clockwise direction. Therefore this loop resistance is 40 plus 60 plus 20, that is equal to 120. Second loop resistance is 10 plus 40, that is equal to 50. Third loop resistance is 60 plus 15, that is equal to 75. The resistance which is common to 1 and 2 is equal to 40, the direction is minus 40, minus 40. 1 and 3 is 60, minus 60, minus 60. And 2 and 3 is 0, 0. I1, I2, I3, V1 is equal to 100, V2 is equal to 0, V3 is equal to 0. I solve the equation, I1 is equal to 2.5, I2 is equal to 2, I3 is equal to 2. Now the current flow through the 60 ohm resistor is 0.5. Here this is 2.5. I1 is equal to 2.5. Here this current is 2 amps. This current is 2 amps. Current towards this point is 2. Leaving the junction is 2. Therefore current flow through AO is equal to 0. So here 2 into 10, that is equal to 20 volts. 40 into 0.5, that is equal to 20 volts. 2 into 15, that is equal to 30 volts. 60 into 0.5, that is equal to 30 volts. Here both the voltages are same, therefore current flow through AO is equal to 0. Current flow in the 60 ohm resistor is 0.5 amps. Problem number 2. In the circuit shown in figure, use mesh analysis to find out power delivered to the 4 ohm resistor. That's the question number 1. Number 2. To what voltage should the 100 volt battery be changed so that no power is delivered to the 4 ohm resistor? No power means there is no current. I2 is equal to 0. First I have to find power delivered to the 4 ohm resistor. There are 2 loops. This is loop 1, this is loop 2. This is I1, this is I2. I can form the Maxwell's mesh matrix. The diagonal elements are 2 plus 3, that is equal to 5. Here 3 plus 4, that is equal to 7. 3 ohm resistor is common to 1 and 2. The direction is minus 3, minus 3. I1, I2, this is 80 plus 40, that is equal to 120. 100 minus 40, that is equal to 60. I can find I1, I2. I1 is equal to 39.23 amps. I2 is equal to 25.38 amps. Again I redraw the diagram. This is 39.23. This is 25.38. I know the current. I can easily find the power dissipation. P is equal to I square into R. 25.3 and the whole square into 4, that is equal to 2576.58 watts. So the first question is power delivered to the 4 ohm resistor is 2576.58 watts. Next, what voltage should the 100 volt battery be changed so that no power is delivered to the 4 ohm resistor? Here I2 is equal to 0. 5 minus 3 minus 3 7, I1 0, that is equal to 120 minus 40 minus x. I solve the equation, x is equal to 112. I substitute here 40 minus 112, that is equal to minus 72. 5 minus 3 I1 0, that is equal to 120 minus 72 minus 3 7. Okay. I know I1 is equal to 24 volts. Here 5 into I1, that is equal to 120. I1 is equal to 120 by 5, that is equal to 24 amps. 5 into 24, that is equal to 120. Minus 3 into 24, that is equal to minus 72. Correct. Here I have to find what is the voltage so that no power is delivered to the 4 ohm resistor. This is minus 72, already one battery is there, 40. So minus 72 plus 40, that is equal to minus 32 volts. Problem number 3. What is the voltage across A and B in the circuit? That is the question. In the circuit, 4 resistors, 3 60 ohm resistor and 100 ohm resistor, and 3 batteries, 60 volt, 120 volt, 120 volt. This is A, this is B. The question is voltage across AB. I redraw the diagram like this. Same diagram I redraw it. I mark the, this is minus, this is plus. This is plus minus, this is plus minus. I can find I1. I1 is equal to 60 divided by 60 plus 60, 120. That is equal to 0.5 amps. So current flow in the circuit is 0.5 amps. Current flow in the circuit is, voltage is 120. 120 divided by 160, 100 plus 60, that is equal to 160. That is equal to 0.75 amps. I can find the voltage across VA. Voltage across VA is equal to 0.5 into 60, that is equal to 30 volts. Voltage across VB is equal to 0.75 into 60, that is equal to 45 volts. Again I redraw the diagram like this. This is 0.5 amps, this is 60 ohms, this is 120 volts, this voltage 120 volts. Again this is 60 ohms, this is 0.75 amps, this is A, this is B. We have to find what is the voltage across AB. Here the voltage drop in the 60 ohm resistor is 60 into 0.5, that is equal to 30 volts. This is minus, this is plus. This is plus, this is minus. Here this voltage drop is 60 into 0.75, that is equal to 45 volts. This is plus, this is minus. I add these two, that is 120 plus 45, that is equal to 165. This is plus minus, this is plus minus. Therefore voltage across AB is equal to 165 minus 30, that is equal to 135 volts. Voltage across AB is equal to 135 volts. Problem number 4. Calculate the current supplied by the batteries and potential difference between A and B. The circuit contains 5 resistors. This is 20 ohm, 60 ohm, 80 ohm, 30 ohm, 40. A, D, B, C. The source voltage is 100 volts. There are 2 loops. This is loop 1, this is loop 2. The loop current direction is positive to negative. This is loop I1. Here this is positive to negative. This is I2. Now I have to form the Maxwell's mesh matrix. The first loop resistance is 20 plus 40 plus 30, that is equal to 90. That is the diagonal elements. The second loop resistance is 80 plus 60 plus 40, that is equal to 180. Which resistor is common to 1 and to 40? The direction is same. Here I1 is the same, I2. Both directions are same. Therefore plus 40 plus 40. I1, I2, that is equal to V1 is equal to 100, V2 is equal to 100. I can solve I1, I2. I1 is equal to 0.959 amps. I2 is equal to 0.342 amps. I redraw the diagram, the same diagram, to check the Kirchhoff's current law. Current supplied by the battery is equal to I1 plus I2. This is I1 plus I2. Therefore 0.959 plus 0.342, that is equal to 1.301 amps. Current supplied by the battery is 1.301 amps. I1 is equal to 0.95 I2 is equal to 0.342. Here this current is 0.342, here this current is 0.959. So current towards the junction is 0.959 plus 0.342, that is the current leaving the junction is 1.301. The second question is find the potential difference between A and B. Here VDB, the voltage across 60 ohm resistor is 60 into 0.342, that is equal to 20.52 volts. Voltage across AD is equal to 20 into 0.959, that is equal to 19.18 volts. So voltage across AB is equal to 20.52, that is VDB minus VAD. 20.52 minus 19.18, that is equal to 1.34 volts. So current supplied by the battery is 1.301. Voltage across AB is equal to 1.34 volts. Problem number 5. 6 resistors and 1 voltage source are connected as shown in figure. 6 resistors 40 ohm, 20 ohm, 50 ohm, 100 ohm, 30 ohm and 60 ohm. Voltage is 120 volts. The question is find the branch currents. What is the current in AB, BC, CD and DA and DB? That is the question. In this problem, there are 3 loops. This is loop 1, this is loop 2, this is loop 3. The loop currents are I1, I2, I3. The loop current direction is clockwise. This is clockwise, this is clockwise, this is clockwise. My aim is to find what is the loop currents. For that I have to form the Maxwell's mesh matrix. The first step I have to find the diagonal elements. First loop resistance is 100 plus 40 plus 60, that is equal to 200. The second loop resistance is 40 plus 20 plus 30, that is equal to 90. Third loop resistance is 30 plus 50 plus 100, that is equal to 180. Which resistor is common to loop 1 and loop 2? That is 40 ohms. The direction is minus 40, minus 40. Which resistor is common to loop 1 and loop 3? 100, minus 100, minus 100. Which resistor is common to loop 2 and loop 3? 30 ohm, minus 30, minus 30. I1, I2, I3. V1 is equal to 120, V2 is equal to 0, V3 is equal to 0. I can easily find the I1, I2, I3. I1 is equal to 1.125 amps. I2 is equal to 0.75 amps. I3 is equal to 0.75 amps. I redraw the diagram to verify Kirchhoff's current law. I1 is equal to 1.125. This is the current in the flow in the 60 ohm resistor. R in the branch AC is equal to 1.125. Here the difference in current will flow in the 40 ohm resistor. I1, I2, I1 minus I2, that is 1.125 minus 0.75, that is equal to 0.375. That is, this current is I2, this current is 0.75. Here this is 0.375, this current is 0.75. The I3 is equal to 0.75. Therefore, current towards the junction is 0.75, current leaving the junction is 0.75, current flow through the 30 ohm resistor is 0. Here this is 0.75. Here this is 0.375. 0.375 plus 0.75, that is equal to 1.125. Kirchhoff's current law is verified. So the current flow through the branch AB is equal to 0.75, BC is equal to 0.75, CD is equal to 0.375, DA is equal to 0.375, DB is equal to 0, AC is equal to 1.125. With this, I conclude my lecture. Thanks for listening.